My name is Matthew. I work for Oracle. I'm here to talk about serverless and the serverless product that I work on, which is called the FN project. So I'll talk a little bit about what serverless is and isn't, talk about why I think you should care about it. We'll talk about what FN is and isn't, a little bit about how it works, and then I'll let you go and enjoy the rest of the conference. How's that? Okay. So I need to get my mouse over here. Wicked. Yeah, okay. So I'm Matthew. I live in Bristol, is on the right, and I work on Team FN, which is building the FN project within Oracle. There are around 30 or so people working on FN, and we're split between Bristol and Oakland, California. So FN, the project we've been working on for around, well, most of us for around a year, some people for a lot longer. It's an open source serverless compute platform. So how many people, can I ask for a show of hands, like how many people know what I mean by serverless compute platform? Most, half, maybe a bit more. How many people have used serverless compute platform? A dozen, maybe, 10. In production? 6? Okay. So it seems like it's going to be worth just spending some time kind of deconstructing exactly what I mean by this so that we all understand each other. So I'll crack on with that. So, excuse me. So FN is open source, right? It's developed entirely on GitHub. We have a public Slack where we discuss all our technical issues, and we're Apache 2 licensed, so anyone can download and use FN for whatever purpose they want. Although it's sponsored and I'm employed by Oracle, there's no restrictions on who can use it and what they can use it for or where they can use it. One of the key selling points of FN compared to a platform like AWS Lambda is that we are standing up in opposition to vendor lock-in. So we're trying to be open, encourage interoperability, and being open source is part of that for us. So the next part of my sentence is serverless, right? So serverless is a much abused kind of laughed at word because it's so vague and there's obviously servers. It's silly. And I think if you've got your wireless router and cracked it open, you'd find there's quite a lot of wires in there as well. But the point is that, not that there aren't any, but that you don't, as a user of this thing, have to worry about them. So in that sense, maybe you could consider that a database as a service is serverless, where you're kind of consuming something that someone else is managing it and you're not worrying about the servers. But what's different here is that it's a compute platform. So what we do and what serverless compute platform does is we take user-submitted code and run it on demand in response to a particular kind of event, or something's happened, and we take the code that you've given to us and we run it, and it provides a response, and then that's the end of it. Okay, so serverless compute platform is that kind of model of execution where you give us a bunch of code, somehow, I'll talk about how in a little while, and when a certain event happens, some detail about that event is passed to us, we pick up your code, run it, the code provides a response, and we are responsible for managing the life cycle of that code and the infrastructure that it runs on. And so serverless compute platform is commonly called functions as a service, or a FaaS platform, and I'll call it that, I guess, because it's like the shortest way of saying it, FaaS, right? So in this sense, functions are not like functional programming functions, or they're not like mathematical functions where they're kind of side effect free and referentially transparent. They're functions in the sense of being like a function in your source code. They're a small, self-contained little thing, single purpose, ideally. I don't know what kind of source code you write, but when I'm trying to write code, which I do sometimes, I try and make my functions small, single purpose, kind of self-evident what they do, independently testable, reusable in different contexts if that's the kind of appropriate nature for that particular function, and ideally kind of easy to understand. I work on a team of other developers, and I want to be able to read their code, they want to be able to read my code. So like the kind of size and ease of maintenance is a key thing. And the fact that we're running your functions as a service, or FN runs your functions as a service, means basically that you provide the functions and we provide a service, which is to say we take care of the life cycle of your code, starting it, getting inputs to it, making sure that there's adequate policies around retrying if there's any kind of failure, that kind of stuff. And one kind of key thing about a FaaS platform, typically, is that they deal with scaling of functions, by which I kind of mean that if there's more demand for a particular function, then more copies of that function will be created to satisfy that demand. And conversely, when the demand dies back down, copies of your code will stop running, and ideally, and I think pretty much this is a kind of selling point of FaaS, when there is no demand, there is none of your code running, and all the major platforms say, in that case, you don't pay anything. So there's a kind of scale down to zero in terms of cost that FaaS platforms offer you. Okay, so hopefully we're all clear on what I mean by a serverless compute platform, and I hope we all knew what open source meant anyway. So FN is the open source, one of the open source serverless compute platforms. It's not the only one, I should say. So now you know what it is. Perhaps you reflect for a few minutes, and then the obvious next question is like, why should I care about one of these things? And if you come and ask me that question, the answer you'll get depends on exactly what kind of person you are when you're asking. So who in the room is a developer or a programmer or a software engineer of some kind? It's almost everybody, which makes me pleased that I put that slide first. Answers for developers. So I have a friend who works as a scientist, and he uses Python a lot in his job, but he's not a software engineer. And he uses Python rather like a sort of advanced calculator or something like that. He solves specific problems. He's really not interested in like software engineering as a discipline. He just wants to be able to run his code. And he sees like with FaaS, he can care just about his code. He doesn't even want to bother running a web server. He writes Python, but was it Flask or Django or something in Python? He doesn't want to know about those. So with a serverless platform, he's able to just put code somewhere and have it called on demand. And one of the services that the platform provides is hooking that up to incoming requests through the web, or through a queue, or through, however else you manage to hook it up. Then, if his function becomes incredibly popular, like I said before, it's able to scale out transparently from his point of view, and like limitlessly with a little asterisk, because obviously there are limits everywhere. You can imagine saturating an entire data center with millions of copies, billions of copies of your individual function. But long before that becomes a problem, I suspect he would start to worry about how much it's costing him to basically rent out a whole data center at once. So there are limits that you can typically apply in terms of maximum like cost per minute that effectively that you can consume. Otherwise, a denial of service attack becomes like denial of your wallet. It's down there. The serverless or FaaS development lifecycle around build, test, deploy, and then just like have the next idea, build, test, deploy, is very much focused around the kind of iterative development process that's encouraged by all the modern software development practices. So it's a very natural fit for developers who don't really want to have to deal with, okay, build, test, provision a server, apply all the latest patches, all that kind of extra stuff that isn't related to deploying your service or running your service. You don't need it. So it's faster for you to just, iterate through things, and it's cheaper for sure. Almost, I would say, as far as I know, all of the publicly available hosted FaaS platforms have a free tier. But even after you've consumed all your free tier, it still costs like microdollars per invocation of a particular function. Typically, you'll pay for the product of, the length of time your function runs for, measured in tens or hundreds of milliseconds, and the amount of memory that you allocate to it, and other resources like CPU, network bandwidth, disk I/O bandwidth, whatever, they tend to scale proportional to memory. So you really have one degree of freedom upon which you can size your function, just how much memory do you want to give it. And then it's up to you to make it run quickly so it takes less time, and the cost will be typically the product of those two things. And like 4 or 5 leading zeros after the decimal point in how many dollars it costs, or euros per invocation. So thank you for your question, all you developers. Are there any people here who consider themselves like business managers or engineers, sorry, not engineers, engineering managers, or people who are concerned about the running costs of a business? This is one. I'll talk to you. So similarly, similarly to the answer for developers, it's cheaper, and it's cheaper for teams to deploy things because of the same model of paying per, very elastically for what you use. I had my grammar corrected by someone on the second point, which reminds me of last time I was in Europe, someone asked me if I was Dutch. Is everyone here Dutch? Is anyone here not Dutch? You're all Dutch? So last time I was in Europe, someone came to ask me if I was Dutch. I'm not, I'm English. And I said, no, I'm not. Why do you think I might be Dutch? And they said, oh, we thought so because your English is so good. So I have my English picked up by someone earlier for this. Dev teams get faster with fewer dependencies. I talk about organizational dependencies. There are fewer people involved in the life cycle of deploying code to somewhere where it can be tested and tried out. Reliability of the platform, a lot of things that would typically be the responsibility of the people who have deployed the code, written and deployed the code, become platform responsibilities. So you get a service level agreement with the platform you choose, and that will include things like failure policy, things like uptime guarantees for the service and this kind of thing, things that you might have to monitor yourself, like hardware failure, become the platform responsibility, so there's less for you to worry about and pay people to worry about. And then, yeah, same again, it's easier and cheaper to try things out. And the third group of people who asked me this question are my colleagues. So why should people who want to run a serverless platform, like why should they want to run it? What's the benefit for anyone to run it? And the answer is, it's a much more efficient way of using the hardware. It costs a lot of money to build and run and fill up with computers a data center. And it's a more efficient way to use that hardware spend by getting a much higher density of compute. And we have an economy of scale because a lot of the problems about scheduling, about hardware maintenance, about networking infrastructure that I mentioned are now under the platform's control. They're centralized. And so we can solve them in the same way for all our customers all at once. And by that means, we get the ability to provide a cheaper, to provide the hardware that we've bought cheaper to people who want to rent it on demand. So the last point as well, people are genuinely asking for it because they have use cases where it's unpredictable demand or it's a very event-driven model. So that's the answer there. There's a very clear kind of set of reasons from our point of view why we want to run a service like this. And on top of which, like from my point of view, the technical challenges in building and deploying a service like this are really interesting. They're difficult and fun for me. So that's enough, right, about why you want to run things using a serverless platform. I'd like to talk now about what FN brings, which if you've used Azure functions or Lambda or Google Cloud functions or any of the OpenWhisk stuff, what FN does that's slightly different. So like I mentioned, we're an open source thing and we value interoperability and we don't value vendor lock-in. So you can use FN, you can deploy to any cloud. I'm running it on my laptop. I'll show you an example in a minute. This person who doesn't work for Oracle, and I have no idea who it really is, but he deployed FN to a cluster of Raspberry Pis to do some home automation stuff. So it's like this very event-driven kind of model. How about like when I arrive at home in my car, the garage door opens, or something like a function that does that in response to that event is a very naturally event-driven kind of application. Unlike the big Amazon, Microsoft, Google public offerings. FN considers the container to be defined as, sorry, the function to be defined as a container image. So you can put anything you like in it as long as it's able to react to an event. So with Lambda, for example, they support a specific set of languages, and if you want to use a different one, it's not supported. Containers, like almost any Linux process, can be containerized. And so we have a few languages that we prefer and we provide a lot of help with, but really people write functions in Bash. People write, like, why would you write, I don't know, a bit of Java code to resize an image when you could just package up ImageMagick that's got 20 years of development behind it into a container and just run that as a function, right? So there's a lot more flexibility. Where are we? Oh yeah, independent, as I've said a few times, and a strong enterprise focus. So what I mean by that is that if you were to sit down, you all had your hands up as being programmers, so you can imagine what it might take to write a system which responded to incoming requests by starting a container or doing some bit of computation and responding to it. That's really not like hugely challenging. I suspect most people could get it done in a few days if they put their minds to it. But to have it done in such a way as it operates well at high scale, makes good, like, efficient use of the underlying hardware, that it has like high guarantees around security. That is like, there's a lot of details there and a lot of devils in those details. So writing a good one, which is by our definition something that we would encourage you to want to run production workloads on top of, is significantly harder. So that's what I mean by kind of enterprise focus. Like, we want people to run production workloads on FN, and we're engineering it so that that's possible. So I just talk a little more about the containers as functions, because that sometimes causes confusion, because how many people are using containers already to deploy things to their production systems? Maybe a third of the people. So typically, you would package up your application server or your web server or something into a container, deploy that, and it would sit there for a long time responding to multiple requests. And the function container is different, right? Because it's short running, it's ephemeral, there's no state. If you want state, you have to write it somewhere else, like a database. You can't rely on hitting the same instance of your function on subsequent requests. So you can't even store state in memory. And they're event-driven, so there's a very specific model of having an event that looks like a particular thing and responding, and then that's your job done. So, enough talking, perhaps. I'd like to offer you a demo of just like the hello world of FN project, so we can see what it's like. And if I can use my Mac, which isn't a guarantee, oh, it's worked that time though, then I will show you. So, because I didn't want to rely on the conference Wi-Fi, I've downloaded already the command line tool for FN, but it's a single curl command that you can find on our website, fnproject.io. So, all the action is going to be happening in the top terminal. So, can people read that at the back? No. What if I big it up? Like that. Acceptable? Good. How about in the middle? I'll try that. OK, so the top terminal then, which I'll just make full screen, because it's the only one I'll use for now. We have this tool, FN. There you go. It's a command line application. It's written in Go, this one. And we can FN init runtime, and I'm a Java programmer kind of by my career, so I would typically write my functions in Java, but we have support for boilerplate, not boilerplate, sort of templating a function in a few different languages. So run function boilerplate generate, brilliant. And what do you get? So who's like familiar with Maven here as a Java programmer? Okay, there's quite a few people, so you're probably familiar with a pom.xml, and source main, Java, blah, 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 source test Java, blah, blah, blah. There's one extra file that we've created at the top called func.yaml, which just contains like a tiny bit of metadata about the function, specifically like what it's called, which is going to be called functions because I've created it in a directory called functions. It's probably not the best name, sorry. Right, and if you have a look at the file, source, main, Java, no syntax highlighting, sorry, but it's pretty simple, right? There's a method, and the name of this class and method are specified in func.yaml, so that's how it knows where to route the request to. The method takes a string. If the string's not there, it says world, and then it says hello to that, that person, right? So, fn run, right? And now what's happening is container image is being built, and, oh, it's happened already. Container image is being built, and the code was being executed right there. And I can equally echo Codemotion to fn run. There was no rebuild of the container there. It says building, but it wasn't. It just knew that there's code hasn't changed. It doesn't need to rebuild it. But hello, Codemotion, we get here. So that's fn run has not used a server of any kind. This is entirely like a local development lifecycle. So it's built a container containing a container image containing the Java code. It ran Maven build, Maven package, uberjar probably. And then it created like one of these events that I was talking about and sent that to the container, and the code has some of the code has unpacked that and sent the little string that was sent through to the handle request function that we saw, and then we've got a response back. If we want to see what it's like using fn as a service, in this second middle terminal, I'll run fn start. And down here, I can make that a little bit bigger, just so you can see. You don't need to be able to read it, really. But I'm just watching Docker PS here. So you can see the fn server container is running now. That's not very exciting, but we'll see other ones spin up in a moment. And it's running on localhost 8080, it says there. So up here now I've built and tested. I'm happy with the hello world behavior of my function. Fn deploy. We namespace our functions with a thing called an app or an application. So if I give it an app of Codemotion, and I'm going to give -- local, which I'll explain in a moment. So now the fn server is able to serve requests which will use that container, that function, which I've just defined. And you can see that if I do fn call the app, I called it Codemotion, and the path was /functions because that's what I did. Okay, so you can see in the server logs, it started running the container. And down here now, we've got two containers running. So we've still got the fn server running, but we've got also the functions 002 running. And it's returned its response, right? You see it up there. So it's now been up for 19 seconds, and it's paused, which is using Docker pause, which uses the C groups freezing to just say, like, no CPU time for you, Java process. You just sit there consuming no resources. And this is now timed out because it was waiting to see if another request was going to come in. And if it had, then we wouldn't have had to start up a whole new container to service it. So this is an optimization that's done by pretty much every FaaS platform in order to provide a better quality of service. They will reuse instances of a function to avoid the thing where it starts up for the first time, which is typically called the cold start, right? And that's longer. I can show you, because fn call is just an alias for curl. If I curl -v my server local host, it's done it, and one of the headers in the response is how long it had to wait for the response, how long the fn platform had to wait for the container to provide a response, right, which is about half a second here, 505 milliseconds. But you can see it's still running, and if I call it again, before it times out, this time the fn fxlb wait is 159 microseconds. So that's a significant performance improvement. And the amount of time that these things stay alive for is configurable. That's one of the things that you can tune in your func.yaml. There might be, depending on how the person who's running FN for you sets it up, there might be a cost associated with having them. But seeing as they're consuming no CPU and only a small amount of memory whilst they're paused, then it might or might not be more expensive. So pretty much all functions are hot functions. It's possible to say the wait time should be 0, just shut down after every single request and have a cold start every time. And you might do that if you value the absolute guarantee of having a clean execution environment every single time over a quick response. But typically, I think people are happier with like a faster response. And once you get more than one request every 30 seconds, you basically have like 0 wait time for your container. I'll just have a quick look whilst we're here at what else is in func.yaml. It's got a name, a version, the runtime, which provides a bit of a hint about how it was templated, the entry point, like I said, the name of the class and the method, a couple of images, and the format HTTP, which is a specification of what the event looks like when it arrives at the function. So, can I do that? No. Hang on. Can I do that? Excellent. So what's going on, like under the hood, is your code got wrapped into a container image, like I said, and then the content of the event that triggers the execution of it arrived at standard in, and your output was sent to standard out, and your logs were sent to standard error. And if anyone knows anyone who's deploying stuff to production with a programming language that doesn't have access to standard in, out, and error, like, please come tell me about it, because that's kind of interesting. Sorry about that. It's a very flexible contract because this is how people write Bash functions or Haskell functions or Rust functions or any other language you can think of by just these like completely standard POSIX input and output mechanisms. So what exactly arrives on standard in? When I did echo Codemotion to FN run, it wasn't literally the string Codemotion that arrived on standard in. It gets wrapped up in an object that looks a little bit like this at the moment. It's got a body which did have Codemotion in it, and it's got some metadata about where the event came from, when it was generated, how it arrived, that kind of thing. And this is what, at the moment, the input format looks like. But last week in Copenhagen, there was KubeCon, and one of the things that my teammates demoed there was that we are now moving over to support this, an industry standard CNCF event format called cloud events, which looks pretty much the same, actually, and it's not really a coincidence. Because several members of our team were working with the CNCF to define this. So it's a bit more wordy because it caters for a wider variety of situations. But cloud events are what's coming up. One thing we get asked sometimes is, if you're dealing with streaming data, how can you encapsulate that in a JSON object? Because JSON, you need to read all the way to the end before you know it's a valid object. The answer is, that's what format HTTP meant in the func.yaml I showed you. JSON and cloud events that don't support streaming at the moment until someone's worked out how to do it. So we have other formats which do support streaming data. The other option is to just send in a URL which which we can stream the data from, or you can, from inside your function. So on the CLI, you saw init, which just unzips some code that looks like a function. Run, I've just explained what run did. Deploy, I'll jump ahead. Deploy builds the image, pushes it to a registry, although it didn't when I did it because I put --local, but typically if you're running FN somewhere else, it needs to be able to get the image, so push it to the registry and push some metadata saying, this URL, when someone calls that, please use this container image to service that URL. And then, when someone calls it, the idea is, we can do like a Docker pull of the image, and then run it, and then give the response back. But that seems like a very, very easy optimization, and we certainly do this, to when someone says, this container image corresponds, represents a function, we think, oh, well, you're probably about to call it then, and we can start the pull before you actually make a request. So where it says lazily, it's actually eager now. And then the other command you just saw me use is call, which is just the same as the curl, but with the wrapping up into the JSON object as well. So dealing with JSON input in different languages is more or less easy depending on the type of language. And for these 5 languages, we have created a thing called a function development kit. The Java one's probably the most complex because it's the one that's got like the highest amount of boilerplate to just read some JSON and turn it into an object. The Python and Node ones are very short, but it's just what the FDKs do is they deal with reading that JSON into something that looks like an object. And they're not all the same as each other because they sort of correspond to the style and the conventions of the languages, so that it just looks, if you were a programmer of that language, as you kind of want it to. If you don't want to use one of these languages, like by all means, I keep saying we can support anything containerized. As long as you've got a func.yaml and a Dockerfile, you're good to go. And the kind of Dockerfile we recommend is a multi-stage Dockerfile. So multi-stage Docker builds have been available since 2017. And it's essentially one Dockerfile which does 2 builds. The first one does like a compile, and then the second one starts again from Alpine latest, this line here, which is a 4 or 5 megabyte base image, and just copies the built binary from the previous stage. So you end up with a final runtime image that doesn't contain all the compile tools. Small images are like one of the best ways to reduce cold start latencies or Docker run latency in general. When a request comes in, this is our kind of internal architecture. When a request comes in at the top, we have a router or a gateway which looks up the route and says which container image to find. Don't worry about the message queue. I'll talk about that later maybe. We find a slot, so amongst these blue container slots, like, is there any machine available to run with enough spare memory to run this thing? Hopefully, if we've done our job properly, pull the image, or it should already be cached, run it, and return the results. And the question is, where do we run all this? I already mentioned KubeCon earlier, so you might not be surprised to hear like that we've jumped. Well, we were already on the Kube bandwagon, really. But what we don't do is run user functions in Kubernetes, right? We run all our control plane in Kubernetes, and we have, we have Helm charts. Oh, there's a title. We have Helm charts here for you to be able to deploy FN into a Kubernetes cluster and get a scalable version of our control plane. And we're still looking, as Kubernetes gets bigger and more fully featured and more powerful, integrating more tightly with it. But at the moment, we don't let Kubernetes run your function containers. And why not? Because it's actually too slow. We found there's between half a second and 1 second scheduling time that Kubernetes adds to a pod start, which is like, we don't want to add that to, we don't want to make the cold start problem any worse. So the other thing is standard in, standard out aren't readily available for Kubernetes managed containers. And there are some issues with scale, especially around networking. But that said, these are all technical problems, not philosophical problems, and we're working with the Kubernetes people and the CNCF to improve our support on Kube. So that's like a lightning tour of serverless and what FN does now. What's next for FN? So my team and the 25, 30 people that I mentioned at the start who live in Oakland and Bristol are working on a hosted FN as a service, which will be run on Oracle's public cloud, which I'm sure you all know about. And that should be launched later this year. We're hoping to launch that later this year. I personally, as someone who does kind of community engagement, I'm very interested in having more people contribute, more people from outside Oracle. We're already working with CNCF. We're trying to get other industry partners to help us out. And so more contributors. Could be you if you spot a typo in any of my slides or any of the other documentation. And more collaboration with other companies, with other public clouds, and more standardization to encourage interoperability and allow people to move on the basis of quality of service and price, rather than being locked into a particular kind of public cloud because they've got lots of hard-coded stuff that only works on that particular one. So at that point, I'll go to my thank you very much slide. I've been Matthew. It's been a pleasure talking to you in this very hot room. I hope you enjoy the rest of Codemotion. I'll be here all the rest of today and tomorrow. So if you have any questions, we're out of time now, but please come up. I'll probably still look the same as I do right now. So come up and ask me about serverless or FM project or Oracle or anything. I'll talk to you as much as you want about it. Thank you very much.